I'm very pleased now to introduce the main speaker for today, Adnan Khaleel, a longtime colleague and friend of mine, a really sharp, intelligent, motivated, passionate HPCer, now also like me an AIer and into quantum computing as well. Today, he is going to talk about using Antigravity like a pro, using the command line interface, and he'll also talk about the SDK and science skills. Adnan, thanks for joining us.
Thank you very much, Jay. I hope all of you can hear me.
Yep.
And hey, really excited to be here. It's always great to get in front of the community and spread some of the knowledge that I've gained over the past years. And as Jay mentioned, we both work together as part of the Google HPC group at Google Cloud. So for those of you who had attended a few weeks ago, I had presented, I'd done a session on Antigravity, the IDE version of it, which, again, if you like an integrated development environment, an IDE is great. Having Gemini integrated or with that is even better. So today we are going to be talking about how do you use Antigravity if you are primarily a command line person. Like, as we know, everybody, a lot of Linux users are command line gurus, especially if you're managing, IT and infrastructure. You do a lot of those tools from the command line. Now, that doesn't mean you're only restricted to things that are associated with like management of your infrastructure and so on. And that's really what the power of Antigravity at the command line does. So we will be exploring things like, how do you analyze tasks? How do you analyze, obviously, your infrastructure? What are some of the basic instructions that you can give Antigravity to give it, to have more autonomy in terms of what it does, and also, ask you for a more detailed plan. So getting into today's session, what it's going to look like is I will cover a few basic points about Antigravity, tell you about some of the tools and some of the features, and with each of those features, I'll try to do a live demo so you have a feel for what it's doing. And then using those features, we'll take on some more complex tasks. Now we'll see if we have time enough to do, some of the more advanced features that we do in the SDK, but I will try to tell you about some of them and at least point you in the right direction. So at the end of today's session, you should be able to do quite a lot of damage just from the command line. I think you can do quite a lot of damage from the command line. Anyways, but so what is Antigravity? For those of you who didn't join the previous session or, just looking for a quick primer, it is really an agentic platform from Google that allows anyone to build. You can use it to write code, you can use it to analyze text, you can give it a task and it'll do it. Could be something as simple as, I want to write a C++ code and I want you to compile it and test it. That could be your prompt, and it'll literally download the C compiler, it'll test it, it'll write some dummy C++ code and make sure that everything runs, right? So the Antigravity platform comes in many flavors. There is the overall sort of chat window and the main orchestrator, which is really the Antigravity 2.0 platform. Now this looks like a normal sort of, Gemini, ChatGPT, or, an Anthropic, a Claude, a window where you would interact with it. Then there is the IDE. That's what we covered, a few weeks ago. And then there is the CLI, which is what we will be looking at predominantly today. And then lastly, there's the SDK, where you can enhance some of the capabilities of your own applications by have it talking to the Antigravity SDK and doing lots of agentic and sub-agentic work. And I'll talk about what subagents are and when you want to use them in a moment here. So one of the key sort of pillars behind why Antigravity is so powerful is that it's got a main agent and it's endowed with a few features. One of them is that when you ask it to do a particular task, it comes up with a very detailed plan. And then based on that plan, it'll then go and spawn off other autonomous agents to act on those plans, and then it'll collect all of those the outputs of those sub-agents, and then it'll verify and make sure that it actually did what the original plan had indicated. Okay, so that's kind of like the high-level overview of anti-gravity. Now, today, as I mentioned, we're looking at the command line version. Now, what it does is it works directly with using anti-gravity in your code base or your scripts or anything that you might have, right? And you can use it to build, debug, and ship code right from your terminal. So it really makes you a super user without even trying. And then lastly, describe what you need, and anti-gravity handles the rest. And that is really, truly the agentic capabilities that anti-gravity brings to the table that makes it very unique from a command line perspective. Now, for those of you who'd like to do this and perhaps try to do some of these demos yourself, actually some of the feature demos you should be able to do. They're not that hard. You can go to the URL over there at the bottom right. It's antigravity.google/download #antigravity -CLI, or you can always scan the QR code. It'll take you to the download page for Antigravity CLI, and you can do that. Now, again, it comes in a few different flavors. If you're based on a Mac or an OS, for Windows, PowerShell, command line, and so on. So make sure you download the appropriate one, and we can go ahead and get started. I'll just leave this on for just a few seconds, so people who are interested in trying to do this themselves, you can go ahead and try this. Okay, so what happens when you first launch Antigravity? Well, you come up with some really cool ASCII art in color, and it's going to ask you to authenticate. You can either use in Google Cloud Project ID if you already have your Google credentials set up, or you can use Google OAuth, or whatever the case may be. But it does present you with a number of different ways to log in. So in this particular case, I used my my Google Cloud Project ID that you see over there to log in, and then after you've done that, it'll present you with how would you like your terminal to look like. It gives you different options. You want the terminal, the light, the solarized, and so on and so forth, which makes it, depending upon what your preferences are. And then once you've done that, well, now you've got the Antigravity CLI available for you to start playing around with. Now, as I mentioned, you can, do all kinds of give it all kinds of tasks and get started. Now, a simple example would be once you have it running. Oh, and by the way you invoke anti-gravity from the command line is AGY. So go to type in AGY, hit enter, and then it'll go over here, and then it'll give you the command line. So all right. So in this particular case, the prompt is, set up a local virtual environment and run this app locally. Now, a lot of the times when I am doing Python development, or if I'm trying to create a script, I navigate into a new directory, and I want a sandboxed environment such that it's not doing something at the system level and potentially being, really nefarious or dangerous, or impact the other computers on the system. So you want to have a sandbox environment, and so basically the prompt is set up a local virtual environment and run this app locally. It could be a Python script and so on. So what it'll go ahead and do is it'll figure out that it has to create, it'll use this command lines to do it. It'll source and activate that particular sandbox environment. It will then look at whatever requirements your particular app, in case if you do have one, or Python script needs, and it'll and if the app is running on a web server and it needs a particular port, it'll enable that, and then it'll run that particular application. In this case, you can see all of that in the left-hand command window, which the Python main.py is actually running. It's running in the sandbox environment. Okay, so that's one thing you can do, fairly straightforward, easy peasy. The next one is you don't have to invoke anti-gravity in order for it to do something for you. You can, use the --p flag, put your prompt in quotes, and as long as you're in the current directory of where your code base is, you can just give it a simple prompt like explain the architecture of this code base, and it will go ahead and it'll do whatever it needs to do. So thereby, you have no user intervention required. So you can do this if you're trying to like get something done simultaneously as you're working on something else. So works really nice. That's another interesting way of using anti-gravity. Now, again, some examples of some like simple sort of user prompts. Are there any bugs in the logic conversion, especially when in this particular case, it's a test application written in Python, and you've got different date formats and so on, and Roman numerals, and it's going to go through the code and make sure that it sort of there aren't any errors, yeah, as you see. Now again, it's set up some boundary cases. It's converting -5, and it realizes Roman numerals must be positive integers, right? So it'll go and fix that code once it's realized that is indeed the case. Now you see some interesting sort of slash commands. I'll come to those slash commands in a moment over here, but you can sort of break up your entire workflow in anti-gravity and make it more specific to what you are trying to do as part of that. So next, okay, and the way you do that is using one of several slash commands. And we'll go through this one by one. I'll switch my display to be my monitor where we'll be running this live, and I'll give you some context, and we will go through this and see together what this looks like. So the first command I want to familiarize all of you with is /plan. So what /plan does is it creates a plan. Now we know anti-gravity does this anyways, but you can ask it to explicitly break up its sort of entire autonomous capability into a few different things. One is the plan. There's another one which we'll call goal, and then there's a few others, and we'll go through that as it's doing this. In this case, we've got some Python code, user_service.py, and we want to plan on refactoring this code to add some asynchronous caching with Redis and log warnings on cache misses and so on and so forth. Okay, so here's like some sample output. I'm going to switch over to another window where we can now look at this live. All right. All right, so hopefully you can see this live. Now we are going to go to hopefully I've tried to make the text big enough so that all of you should be able to see it. Let me know if you can with a thumbs up. All right, thank you. Okay, cool. So I've set up these demos so we can see what's going to be happening over here. And then let's go to 06, synchronous background task. All right. So again, as we go through this demo, let's kind of take a quick look of what is happening. You can run. Oh wait, this is not the one. Sorry, I made a mistake. Oh, sorry, it's feature. All right. So what we're trying to do is demonstrate what the /plan command does, and it forces the agent to write a technical design document with file diffs and everything that's needed as part of this, right? So let's invoke Antigravity. As I mentioned, you do this with AGY. It's going to come up over here, and the prompt is ready. And we are going to give it the prompt that does precisely that. Okay, so, oh, actually, before we do that, I want to show you what services do. It's really like a simple, just a class definition, and it has something. So now you're trying to augment this and enhance it and add some more features to this. Okay, so coming back over here, let's give it the prompt that we are going to be using. And have it sort of go through all of this. Now, usually when you're doing this, well, it's searching through everything in the local directory. It's looking for, source/services.py, and then it's exploring, as you can see in the text over there, what are the various async Redis options, and it's going to come up with, what that looks like. Now, at the end of that, you can see it's created this implementation plan. It's a markup document. And let's open it and see what this looks like. All right, there you go. So let's try to make it bigger. So here you can see, it has this explicit sort of, everything that you've asked it to do, what the goal description is, what user review is required as part of this, and what are the dependencies and open questions, right? And you can go and edit this, and as it's sort of like, if you ask it to go to the next step and say like, okay, as you can see, like, okay, I've seen the implementation plan, looks good. Please review the plan and go ahead and implement those changes. That's what it's going to do. All right. So now that we've done plan, we're going to go through quickly a few others like this, and then we will go on to, oops. Okay, so we looked at plan. Here's another one I want to talk to. The other one is goal. And you can use the /goal command to analyze a README. In this particular example, it's just like analyze the README.md file and update with all the latest code-based changes that have been made. Fairly straightforward. Again, for those of you who write code on a day-in, day-out basis, this is one of the most basic things that you would want to do. It's also one of the most dreaded as well, because a lot of times you've made changes in the code, even though you might have documented. Like now, it's a bit of a pain to go back and incorporate all of those changes in the README, and you want it to be technically correct and accurate and so on. So having goal do that is a great way of doing it. But we're going to do something a bit more advanced with goal, and I think that's what I have in the next sort of example over here. And over here, we're going to analyze some Python code. In this case, it's test_math.py. By modifying the math_libpython file and verifying that the fix is running by running this code until 0 failures remain. So okay, so again, fairly basic. So let's go ahead and look at that example. And let's go back to our window. Okay, so what I will do, just to make sure that we are doing this from scratch. Oh, so by the way, I told you how to invoke anti-gravity. The way you exit is, it's again a /command/exit. There's a few other interesting commands I want to show you. Exit, obviously exits the application and you go back to your original command line. The other one is model, where, if you do /model, it'll give you a way whereby which you can select, different LLMs. So in this case, I'm using Gemini 3.6 Flash. It's giving me a few other options over there, but let's just stick with the model I have right now. So, and anytime you don't like anything, again, escape sort of takes you back. So let's exit this. And as a best practice, I always like to go back to go into the directory where I am executing my my code. So in this case, I'll go there and I'll invoke anti-gravity from that directory. So again, it has, and just make it clear so you don't, oops. And clear, again, is another / command that allows you to clear the screen. Okay, so before we go and try out, our goal command, let's look at these two sort of Python files. And you can see, this is simply doing, it's essentially what you have is like a test factorial. It's doing a factorial function, and, and it's purposely, we've put in an error over there in the final line, a -1 factorial. So how should we handle that? Now, again, these are some of the basic things that, mistakes that most people would make when you're initially programming, any sort of a math function, right? So what does the math.lib look like? And again, it's fairly straightforward, factorial function, which you'd expect, right? It's a very recursive implementation. It calls itself until, you get to 0. And it it returns the dot product of everything that it's done in the recursion. Now, again, notice there is no condition for -1, and that's why it fails. You'll fail with a segfault. So let's now we will take this prompt, and it's essentially the same prompt that you saw earlier. And let's give it to anti-gravity over here. So one of the very first things you might have noticed is right now, it'll ask me if I would like to proceed. And again, this is by design. Now, there is a flag that you can put in so that it always proceeds. I'm not going to, you can find that out quite easily what it is. But it's always a good practice to not do that, because it may do something that you didn't exactly intend if it doesn't let you review. Now, in this particular case, it's asking me, like, it wants to run PyTest on this particular Python file, and it's asking me if I'd like to proceed. So in this case, I will choose option 2 and say yes, and always allow in this conversation for commands that start with PyTest. And you can see it's going through, it's like doing stuff, and it's realized that, as we didn't have a special case for negative numbers, and essentially it's saying like, oh, okay, so this is what's missing. Do you want to accept this change? You can see right there in the bottom. I will go ahead with yes, and now it's going to be going through that, and now it's going to be running it again, looking for other errors, and there you go. So now it's updated the code. It's sort of tested for all kinds of boundary conditions. In this case, again, just for the sake of an example, it was fairly simple. It's just negative numbers, and it's ran that, through a variety of different, integer, well, hopefully positive integers, and even some negative integers, and it's found that, it did not fit. So there you go. So that's a very, very simple example over here. So now let's go back. All right, so we looked at plan, we looked at goal. Now I want to show you another one, which is called Grill Me, and this is actually, in the previous two examples, it didn't really ask you what your objective was, right? I mean, it had a high-level view. I mean, again, they were fairly simple. It could have asked you some more details of, what you would like the anti-gravity agent to do more specifically. You could have told it like, I want to test, in the previous example, I want to test for integers larger than 100 million or 10 to the power of 8 or something like that. But it kind of just assumed as long as it did some boundary conditions, you'd be fine with it. But there is a way of actually having anti-gravity sort of question you and probe you as it's going through its planning stages. Now, this is particularly helpful when you yourself may be on the edge on something, and perhaps having the questioning mode of anti-gravity's logic, ask you some questions, allow you to make some, give it some more boundaries, better boundaries into solving, a particular problem. Now, again, so this is another command, /grill-me. And over here, the prompt is, I want to build a configuration loader module for some Python code supporting YAML and JSON with the environment variable overrides. Again, sounds fairly complex. It's really not that complex, and you'll see in a moment why. And what you will see is it'll go through and it'll ask you these questions. How should the schema validation and typing be handled for loaded configuration files? It'll think about that. Then it'll ask you another question. How should environment variable overrides be mapped and applied to configuration settings? It'll think some more, consume a few more tokens, considering the next question, and so on and so forth. And it'll ask you these questions. Generally it's like a handful, until it's come to a better understanding of how it should go about that particular task. So let's see. Actually, okay, so since that one's fairly simple, and in the interest of time, and I do want to get to a few more interesting sort of demos, let's skip to the next one. And this one is, I think, particularly powerful because, oftentimes, especially from the command line, what power users are used to is running background tasks. Now, you would, type in a command, then you would put in an ampersand at the end of that and hit it, and it would run in your shell in the background. And you can monitor it and see how it's running. Now, you can do something similar with anti-gravity, not so much with the application itself, but the task that it's trying to do. And these are, what we'd normally call an asynchronous background task. Now, in this particular example, you're asking to run a long-running, test code as a background task, and you explicitly, say, run it as a background task. And while it executes, create an MD file explaining what that particular piece of code does. Okay, so this one I think is a good one to show. So let's do that. So let me go ahead and exit from this window. Oops. Six. All right. So let's look at, where I usually start within these demos. And again, it's the ability to run these background tasks, especially ones that take a lot of time. And you can do this for lots of other things, right? It's not just, you can use it for a benchmark that you might be running that takes several time, and you want it to look at the results of the benchmark, summarize it, look for some, maybe some faults or some particular conditions and so on. and to do these in a very asynchronous sort of way, right? And why people like it is because you're not blocked. You can still use the current window of your anti-gravity while that particular task is running and do things that might be associated with that particular task without having to start another instance of anti-gravity. Okay, so before we get there, let's take a look at what this this long task looks like. So it's all right. So essentially something very, very simple, it's saying I'm starting a long task and it has a loop and it essentially goes to sleep. And then it tells you that, which iteration it is in, and finally it'll exit that task, right? So again, very demonstrative, just to show you what this is doing. And let's go ahead and start our anti-gravity. Oh. Okay, so I'm going to copy the prompt, put it in. So it's going to launch the job as a background task. And again, it's asked me for permissions. Do you, allow me to run this Python file? And I'm like, sure, why not? Okay, and it's going to ask for some more permissions. And here's, sort of the creation of this file. It's essentially its plan. So yes, allow creation. Okay, and it's given you a summary of the actions, and essentially is like I started this task as a background process, and it has completed successfully, and it's also created this MD file. Now, I think we should increase the length of the duration. Normally, I'd increase the length of how long this is running, but whilst it's done that, it's also created this other part of our prompt, which we said was to tell us what exactly that particular piece of Python code is doing. Now, again, when you have a very large a repository or lots and lots of source files, this could take a considerably longer piece of time. But in this particular case, it's gone ahead and described that what your Python file is doing, simulates a multi-step time-consuming task, and it sort of gives some more details about that. Okay, so now I think, now that you've got some basic understanding, and we've got like 10 minutes left, I am going to go and show you what I think are some of the most powerful features, and that is called subagents. Now, as you might have guessed, subagents are allow you to spawn off other agents.
And just on time check, we've probably got about 5 minutes left, so we can take some questions. I just want to make sure that got your eye on that.
Okay, so all right, so I mean the rest of the demos really use like all of those other features and build and create some really more advanced complex demos. But I think what the users will walk away with today is how they can do some of these things themselves. So okay, so I'll try to like wrap up in like 5 to 7 minutes, Jay. So one of the main things that you saw even in the previous sort of example is that it was doing some orchestration on its own, right? Even though you didn't, you kind of you asked it, but it had the capability of doing that on its own. So, but you can explicitly launch sub-agents of your own based on different personalities to do certain things, and you can ask it to search certain directories and look for, in this particular example in the prompt over here, for all memory allocation sites using malloc, and once it finishes, summarize the dynamic memory footprint. Again, fairly sort of indicative of the type of source code work that one would normally do. And you can see it's spawned an agent and so on. So I'm going to go to the next one, which I think is a really cool feature and one that I've come to use a lot, and that is subagents, right? So we're going to be using, you know, the agentic capabilities, the background running agent capabilities, and so on. And now we have something called a subagent. Now, the main context window that you interact with in Antigravity, that is, you know, that has a complete context of the task. Now, that main agent can spawn off subagents based on what you've asked it to do. And there's a number of reasons why you would want to have subagents, and I'll go, you know, over that in a moment over here. But the way you invoke a subagent is essentially, you know, this is the format. Although, you know, this is a very sort of explicit format. It doesn't even have to be, you know, like this explicitly sort of mentioned, where over here we've got the type name is research, the role, and so on. Again, this just gives it a lot more context. If you don't provide all of this and just say, you know, I'd like to do a subagent which, you know, searches the code base for authentication and handler definitions, it'll go ahead and do that and pretty, you know, do a fairly decent job of doing that as well. Now, as it's doing this, you know, and you know, the way it does this is the main agent will spawn off a subagent, and you can spawn off as many subagents as you like, actually. And all of these run in the background, and then the main agent acts as the orchestrator. So it is waiting on the results of all of these subagents, collects them, and then sort of presents its summarized finding of everything, you know, that you've asked it to do. So you don't have to explicitly, you know, ask it to, like, you know, poll what the subagents, when they finish, the main agent will do all of that. Okay. So so then if that's the case, then, you know, when do I want agents? When do I want subagents? What is the difference between the two? Well, there's a few, you know, differences, and I've listed like the 5 top ones, which I think really help sort of get the message across. In terms of user interaction, it's only the main agent that gets to talk to you. The subagent only communicates with the parent agent. It doesn't even talk to any other subagent. Scope and ownership, again, the main agent owns the top level goals, overall sort of plans and user session context. And the subagent only owns a specific scoped subtask. Okay, and along those lines, even in terms of the context window, the agent owns the main conversation history across multi-turn exchanges, where, you know, you may have like something like do task 1, and then, you know, task 2. It's a multi-turn sort of an exercise. Whereas a sub-agent operates in a very isolated context window that is destroyed or archived when done. So in other words, you know, main agent's going to spawn off a very, very specific sub-agent to do that, just that particular task. In terms of tools and permissions, now, as you know, we ran some of these examples, the agent saw, you know, the agent asked you for permissions. Can I do something? Can I not do something? Now, the sub-agent only inherits the permissions for that particular task that the agent has asked it to do, and also that the agent has permissions for. So sub-agents don't, you know, ask you for specific sort of permissions. And then lastly, in terms of the life cycle, you know, persists for the duration. An agent persists for the duration of the entire user session, whereas a sub-agent is a very transient sort of, you know, a process. All right. So why use sub-agents? Well, you know, context window management, long tasks with heavy file reading, so you can ask, you know, give it to a sub-agent. It's specialization, you know, again, when something needs to be very tightly scoped, you know, that's a great task for a sub-agent. Parallel execution, as we mentioned, you can have multiple sub-agents running concurrently. Modularity, again, you know, if that's how I think I try to break down complex tasks in a very, very modular way. You'd use the /plan approach to do that. And again, so, but it's not explicitly mentioned over here, but I think it was in a previous slide, is context rot. Now, the main agent, now you give it too much information after, you know, it exceeds its context window, then, you know, you run into the problem known as context rot and hallucinations and things of that sort. Now, because each sub-agent is specialized in just a particular subset of that task, it has very, very small context windows. As a result, is not subject to the type of context rot. Okay, and here's some commands. Okay, Jay, do I have time for one quick demo?
One quick demo.
Okay, so let's pick one that's interesting. Node Slurm. Okay, this one's going to take long, so we're not going to. So, all right. Yeah, let's do this. You know, since most of us over here are from the HPC world, let's do a simple, you know, Slurm batch job tracking and auto resubmission. Now, just so that you have some context, you know, when you have an HPC job that you submit to a Slurm cluster, oftentimes the job can fail, and you know, you may have very little knowledge of why that job fails. Now, in the normal world, and you know, this was my life when I was using HPC, is I would submit a job which I thought would run overnight, but then I'd come back the next day and I find that all of my jobs, you know, hundreds of jobs, have all failed because I made one simple error in either the command line or I picked the wrong VM, and now I've wasted a day's worth of time. Now, in that particular case, you know, having like Antigravity monitor those jobs is perfect, because you know, it can sort of diagnose what the problem is, and it can, you know, sort of you know, resubmit the job on your behalf. So let me do this very, very quickly. Oops, so let's get rid of that. All right, so over here, we've got a number of different things. Actually, let me, and you've got a job submission script, which is in Python. And you know, it's going to do a few things over there. So let's look at, all right, and when I was creating this demo, I was trying to like do this in a multi-turn way as well, but let's do the simple one, given that, you know, we are running out of time over here. All right. Yes, I trust this folder. Now, and by the way, this is, as you might have imagined by now, this is a dummy example. I don't really have a Slurm cluster running in the background, but my file is pretending to be that. But you know, you can, if you're using Google Cloud or even your own on-prem system, you know, in terms of how this would work, it'd be very, very similar, right? So I've submitted my job. It's asking me permissions before it can actually sort of run that dummy job. It's submitted, and okay, so now I can ask it a command. So there you go. So now it's said like, okay, the job ran but encountered an out-of-memory failure. Now, what I would do is, normally, I would have put my second prompt as well, which is what I'm going to do now. And now it's going to pull that particular file and see if it's run properly or not. And it's determined that the job failed with an out of memory error. And it's asking me if it would like me to proceed in making some changes. Now it's gone ahead and decided, yes, you know what, you need to make this particular change the amount of memory from 4 gigs to 16 gigs because that was the nature of the error. And it's gone ahead and made that change, and it's resubmitted the job. So normally, you would run this as an asynchronous process, so you wouldn't explicitly be monitoring that. All right, so I have so many more examples, Jay, but in the interest of time, let's go ahead and take some questions.
Yeah, I think what we'll do is certainly we'll cover this in more detail the next time we have an in-person workshop. We also probably need to figure out a way to schedule a longer session than the normal 45-minute session, maybe an online workshop as well. Would people be interested in an online workshop if it was 2 hours covering anti-gravity, 2.5? It looks like a lot of people would.
Oh yeah, I think that'd be great. No, I mean, that would be wonderful.
It is one of the limitations of this format. We bring this information to people to make them aware and to give them the basics, the fundamentals in a very hourly session. But yeah, it's certainly the case that don't go Adnan from Duval. So don't worry, Adnan's not allowed to actually go anywhere, but we've got him prisoner. But yeah, we'll have to figure out some online workshops. Also, I asked several people to put their questions in Q&A, and now we're almost out of time for Q&A. So would people be interested if we provided an after-the-fact way of reviewing questions that were submitted and answers, the ones we can't get to in a session? Would people check back later? Would you check that web page for that? It looks like a number of people would. So Adnan, I think what we'll do is you, me, and Mary will work on that and answer some of these questions after the fact and link to the event page for it. People will have to then know to go back to that event page, but we'll have to start training folks on that. Let's see what we've got time for real quick. Raghu Ras, after the project definition is complete based on interactive discussion with anti-gravity, is there a mechanism such as history or so to collect critical commands and spec and create a macro to regenerate the entire from scratch to achieve the same goals?
Oh yeah, actually I do that all the time, because initially when I'm sort of experimenting something for the very first time, I might have, I might do some things which are extraneous and not really are not really necessary, right? But then you can just go back to the anti-gravity command line and just ask it, like, give me, the very specific set of commands that achieve this goal without extraneous sort of instructions, and it'll go ahead and give you exactly that. Or you can even be more explicit and say, like, I would like to achieve the same goal and create a Python script or a Bash script. It'll go ahead and do that. So yeah.
All right. Let's see. Someone asked, how can a customer keep track of the token usage count? Could a script or subagent help? There are occasions where anti-gravity could get into a loop. What are the best practices to control expenses, token usage and costs?
Yeah, you could create a subagent and ask it to monitor the token usage and say, I don't know how you would, there is no good way of enforcing it. You could definitely see how, the token usage is going on. Ideally, you'd want this to be at sort of, your account level, such that every user gets X number of tokens, and anytime, they've exceeded their tokens, the jobs don't run. There might be a way of doing it. I don't know off the top of my head, but once you've invoked anti-gravity, you can definitely use a subagent to keep track of your token usage.
Great. See if we can ask one more real quick here. I am very interested in the subagent orchestration and background task capabilities. Are there any scheduled, detailed tutorials planned in the near future to demonstrate these workflows? In fact, there are not for us. There are certainly almost certainly online tutorials about anti-gravity. We'll do this, but Adnan and I will commit to creating a GCACC session, probably sometime in September, October, maybe late September, that goes through more of this in an online fashion and allows you all to follow along at home on your laptops and devices as well. So it looks like for this topic in particular, an online workshop as opposed to an online presentation and demos is called for. I think people would attend that, and let's plan that for maybe late September.